Welcome back to Python to AI. Episode 4. Look at this terminal. I wrote a 5-second countdown. Start at 5, stop at 0. It has been running for 2 minutes. My laptop fan sounds like a jet engine. The number 5 fills my screen forever. By the end of the next 20 minutes, you will know exactly why this happens, the rule that prevents it, and you will build a 15-line number guessing game that uses every idea in this episode. Here is the path: if and else, elif chains, while loops and the one trap everyone hits for loops, nested loops, and our build the guessing game. Start with the simplest control flow tool, the if statement. Code without if statements runs top to bottom, one line at a time every time. An if statement gives your program a fork in the road. A condition is checked. If it is true, one branch runs. If it is false, a different branch runs. Here it is in Python. Age equals 18. Then if age greater than equals 18 colon. Indented underneath, print quote, you can vote quote. Then else colon. Indented underneath, print quote, too young quote. 3 things to notice. First, the colon at the end of the if line. Python uses colons to say a block of code follows. You will forget it once, get a syntax error, remember it forever. Second, indentation is not optional. Python uses the leading spaces to decide which lines belong to the if branch and which do not. The standard is 4 spaces per level. Set that up in your editor and forget about it. In other languages like Java or JavaScript, you would see curly braces. Python uses whitespace. It takes 1 day to get used to, and it makes code read like an outline. Third, the condition after if is just a Boolean expression. Remember from episode 3. Comparisons like greater than equals return true or false. Age greater than equals 18 evaluates to true when age is 18 or bigger. Python takes that true and runs the if branch, and any truthy value works. If name colon, the if branch runs when name is a non-empty string. If items colon runs when the list has at least one item. You do not need to write if name exclamation point equals quote empty quote quote. Just if name. Python handles the rest. 1 fork in the road. 1 condition. 1 decision. That is the if statement. 2 branches is sometimes enough. Often it is not. You want to sort a score into a letter grade. You want to pick between 5 shipping options. You need more than 1 fork. Python's answer is elif, short for else if. It lets you chain conditions together. Here is a grade classifier. Score equals 85. If score greater than equals 90, grade is A. Elif score greater than equals 80, grade is B. Elif 70, grade is C. Elif 60, grade is D. Else, grade is F. Run it with score equals 85. The output is B. Why B? Because Python checks top to bottom. Is 85 greater than equals 90? No. Is 85 greater than equals 80? Yes. Assign grade B. Done. Python skips every remaining branch. 4 rules to remember about elif chains. First, Python checks conditions top to bottom. The first true one wins. Second, only 1 branch runs, ever. Even if the score is 100 and would also pass the B, C, D gates, only the A branch runs. Python stops at the first match. Third, the else at the bottom catches everything not already matched. It is optional. If you leave it off and nothing matches, no branch runs and your program just continues. Fourth, you can have as many elifs as you want. 3, 10, 20. Python does not care. Think of it like a sorting hat. The first rule that fits wins. Everything after is ignored. Now repetition. Loops. Python has 2 loop shapes. We will start with while means keep running as long as this condition is true. Sounds simple, and it is until it bites you. Which is why we are spending the most time on this beat of any in the episode. Count down from 5. Count equals 5, while count greater than 0 colon. Indented, print count. Then count minus equals 1. That minus equals is shorthand for count equals count minus 1. It subtracts 1 and reassigns. After the loop, print quote liftoff quote. Run it. 5, 4, 3, 2, 1, liftoff. Now the trap. This trap breaks every single beginner. It is the program from the cold open. Imagine I forget the count minus equals 1 line. I write the loop body with just the print. Count equals 5, while count greater than 0 colon, print count. No decrement. What happens? Python checks the condition. 5 greater than 0, true. Prints 5. goes back to the top, checks again. 5 greater than 0, still true, prints 5, back to the top, still true, prints 5. Forever, your terminal fills with 5s, your CPU hits 100%, your laptop fan spins up, and Python is happy. It is doing exactly what you told it. The rule is simple enough that I want you to write it down. Every while loop body must contain a line that can make the condition false. If that line does not exist, the loop runs forever. Emergency exit, Control-C. Hold Control, press C. Python raises keyboard interrupt and kicks you out of the loop. Every Python programmer has typed Control-C thousands of times. It is not failure, it is just how you escape. The real fix is not Control-C though. The real fix is making sure your loop variable moves. In the countdown, that is the count minus equals 1. Without it, the condition never changes, and the loop never ends. There is one more tool that makes loops livable, two actually: break and continue. Break exits the loop immediately, jumps out, skips the rest of the body, skips any remaining iterations. Continue skips the rest of the current iteration and jumps back up to check the condition again. Here is the idiomatic Python event loop. While true: read a command. If the user typed quit break out of the loop. If they typed nothing, continue, go ask again. Otherwise, run their command. Notice the loop condition is just true. Literally the Boolean, it would run forever on its own, and that is fine because break is our exit. In event loops, you do not know in advance when the user wants to quit, so you loop infinitely on purpose and break when they ask. 2 ways to leave a while loop. Let the condition go false, or hit a break. If you forget both, you have built a heat lamp. Now the second loop shape. For while is open-ended, you say keep going until some condition stops being true. For is different, for loops walk through a sequence. One item at a time, you do not write a condition. You write for each item. Example: fruits equals the list apple banana cherry . Then for fruit and fruits printf I like curly brace fruit curly . Run it. 3 lines. I like apple, I like banana, I like cherry. The variable fruit is assigned each item in turn and the body runs once per item. For loops are not only for lists. You can loop over a string. For letter in Python walks Python. You can loop over dict keys, file lines, anything Python calls iterable. In episode 6 we will meet more iterables. For now, lists and strings. The other thing you will use for loops for constantly is counting. When you just want to repeat something a fixed number of times. That is what range is for. Range open paren 5 close paren produces the numbers 0, 1, 2, 3, 4. 5 values, but the highest one is 4, not 5. Range stops one short of the end. Same rule as string slicing in episode 3. The stop value is exclusive. So for I in range 5 runs the body 5 times, with I taking the values 0, 1, 2, 3, 4. That is how you repeat a block n times in Python. Range takes up to 3 arguments: start, stop, step. Range open paren 2, 11, 2 close paren produces 2, 4, 6, 8, 10. Start at 2, stop before 11, jump by 2 each time. Negative steps work. Range 10, 0, -1 counts down from 10 to 1. One last thing. Range does not actually build a list in memory. It produces values on demand. That means range 1 billion takes no memory. You can loop over it happily. If you try to write list range 1 billion, Python will build the list and your laptop will think hard. While for when, for each. Pick the one that matches how you think about the problem. Loops compose. You can put a loop inside another loop and the inner loop runs completely for each step of the outer loop. Classic example: a multiplication table. For row in range 1 to 4 : for col in range 1 to 4 : print row times col. Let us trace that. Outer row is 1. Inner col starts at 1, print 1. Col becomes 2, print 2. Col becomes 3, print 3. Inner loop is done, back to outer. Row becomes 2. Inner col starts over from 1. Print 2, print 4, print 6. And again with row equals 3. Print 3, print 6, print 9. 3 rows, 3 columns each. 9 multiplications total. The output reads like an actual table. Another pattern, star triangle. For I in range 1 to 6, print star times I. When I is 1, the string star times 1 is just 1 star. When I is 2, 2 stars. 3, 3 stars. All the way up to 5 stars on the 5th row. That trick, multiplying a string by an integer to repeat it, is a handy Python feature you will use more than you would expect. One caveat on nested loops. The number of iterations multiplies. 2 loops each running 100 times is 10,000 iterations. 300 iteration loops is 1,000,000. You can do a lot of work inside a nested loop. For small sizes, it does not matter. When we get to data in Module 2, we will learn how to replace those nested loops with something vastly faster. Time to build. Our project is a number guessing game. 15 lines, every concept from this episode. Line 1. Import the random module from the standard library. Random comes with Python, no installation needed. Line 2. Secret equals random.randint, 1, 100. Randint returns a random integer between 1 and 100, including both endpoints. Different from range, which excludes the upper end. Randint is inclusive on both sides. Line 3. Attempts equals 0. That is our accumulator. Every guess bumps it up. Line 4. Print a welcome. Quote, I am thinking of a number between 1 and 100. Quote, now the loop. While true colon. We are looping forever deliberately because we do not know how many guesses the player will need. Break will get us out when they win. Inside the loop. Guess equals int open paren input open paren quote your guess quote close paren. That is the input to int pattern from episode 3. Input gives us a string. Int converts it to a number. Without the int wrapper, we would hit the 2525 bug all over again. With it, guess is a real integer and we can compare it numerically. Attempts plus equals 1. One more guess counted. The cascade. If guess less than secret, print quote too low quote. Elif guess greater than secret, print quote too high quote. Else they got it. Printf quote correct exclamation you got it in curly brace attempts close curly tries quote. Break, out of the loop, done, run it. Python picks a secret number, you guess 50. It says too low or too high. You narrow it down. Maybe 75, maybe 85. Eventually you land on it and Python tells you how many tries it took. If the player types quote ABC quote instead of a number, Python raises an error. We will handle that properly in episode 7. For now, play nicely. Link to the full file is in the description. Before we close, 3 shapes you will see in real Python code again and again. Name them and you will recognize them every time. First, the guard clause, and if at the top of a function that handles the bad case early and exits. If the input is missing or invalid, return. Do not indent the rest of the function inside another if. Exit bad cases at the top. Keep the main code flat and unindented. Your code reads cleaner. This pattern is everywhere in professional Python. Second, loop plus accumulate. Initialize a variable. Loop through items. Update the variable each time. Total equals 0. For n in numbers, total plus equals n. You have already used this in the guessing game with the attempts counter. It is the basic shape of counting, summing, and building lists. Third, the search pattern. Loop through a collection, check each item. When you find what you are looking for, break. You do not have to keep searching past the match. And breaking out makes that explicit. 3 shapes: guard, accumulate, search. Once you know the names, you will start seeing them in every piece of code you read. That is episode 4, if elif else, while in 4, the infinite loop rule, and a 15-line game that uses all of it. Next episode, functions, reusable blocks of logic. Subscribe and hit the bell. Drop a comment with what you want to build. I read everyone.